So this presentation is going to be over the Te Mihi station in New Zealand, and what's really interesting about Te Mihi is that it was an improvement upon the design of the Wairākei plant, which was actually built in 1958, and it was only the second geothermal plant in the world. The first was actually in Italy, in Devil's Valley. And so New Zealand actually has this really great history with geothermal power, and they were able to use all the knowledge of their engineers at Wairākei over at Te Mihi, and it was commissioned in 2014. This presentation is going to take you into a little bit of some of that design. So this here is an overview of the Te Mihi unit, and if you don't know much about how geothermal plants work, they get the geothermal fluid, a combination of the water and the steam that is located beneath the earth, and they bring this up through the wells, and it comes in through pipelines as a water and steam mix. And Te Mihi is known as a flash plant, and what flash means is that water is converted to steam by a pressure drop instead of a temperature increase, and so that's how it is separated at a flash plant. And Te Mihi is actually a double flash plant, meaning they do this process twice to get the absolute maximum amount of steam possible. So it ends up being a really efficient process. The only drawback is the initial cost of the equipment for these kinds of plants. But as the steam comes in through the steam turbines, it turns the rotor of the turbine, and this in turn creates a mechanical energy. The mechanical energy goes to the generator and is then converted into electrical energy, and then this is stepped up to the national grid in the form of electricity at 220 kilovolts. Now you'll see towards the bottom of this picture that some of it talks about being re-injected or going towards re-injection. And what that means is that there is two typical ways that a geothermal plant can get rid of the fluid that it can't use or that didn't turn into steam. And re-injection is when it's pumped back into the Earth's resources down beneath the surface so that it can then mix with the fluid that's already there in the geothermal pool and be used again. Previously, Te Mihi and Wairākei used to discharge it into the Waikato River, but due to some environmental changes in 2006, their now main focus is on re-injection because it was leading to environmental changes in that river. You can see also they use a cooling water flow to cool down some of the steam, and they actually get their water from the Waikato River, and it is useful because it runs a few degrees cooler than normal, so that's really helpful towards the plant. And you can see that this station's total output is 156 megawatts, and it's actually run on two units that I'll be discussing later, which are the Toshiba 83 megawatt units. So here we get our first look at one of the steam turbines made by Toshiba in the Te Mihi plant. And like I've stated previously, they have two 83 megawatt steam turbine generators. And the cost of these two alone was $94 million in US dollars. And to put that in perspective, the entire Te Mihi edition was actually $623 million US. So obviously just those two turbine generators alone comprised a huge part of the plant. And I think what's really interesting about these generators is a lot of people don't realize how important it is in a geothermal plant to get all the water out before it goes through to the blades, because any water droplets whatsoever within the steam are going to cause damage, like bullets hitting those rotor blades. And because a typical power plant turbine rotates about 1,800 to 3,600 rotations per minute, and they call it dry steam when there are no water droplets left. And a lot of people don't realize that steam can be dry. One of the greatest things about these turbines is they were invented by this guy named Charles Parsons sometime in the late 1800s. And the rumor or the story is that he sketched this design for them on the back of an envelope. And they took his design, these engineers, and they tried for like 25 years and spent, I think it was $300,000 trying to improve upon this design that he just sketched out kind of off the top of his head, but they could only increase the efficiency by 2%. So clearly he knew what he was doing. And what he came up with, and this was an improvement to the steam engine, was to have a spinning rotor and the blades around that go around, and they gradually increase in size, what he called small fractional expansions over a large number of turbines in series. And that would improve the velocity of the steam. And because of this, a steam turbine is a lot more compact than a steam engine. So back in those days, that was a great technological advancement because they needed that for ships, because clearly a ship's workspace is pretty limited. Now, you'll see here on some of these photos that some more of the generators here. Te Mihi actually uses two different kinds of pressure levels, intermediate and low pressure. And you'll see around the plant these signs for IP and LP, and that's for intermediate pressure and low pressure steam. Now, what I said before about how hard the water would hit the blades, it'd be hitting at approximately 209 kilometers per hour or 130 miles per hour, because water typically makes up 80% of the collected geothermal fluid. So clearly that's a problem that they have to address in this plant. But Te Mihi used a lot of technology that was not available at Wairaki, and they actually won an award in 2013 from Power magazine for their excellence in power plant problem solving. And they added 574 gigawatt hours per year of energy compared to Wairaki. So clearly, considering how long Wairaki has been around since 1958, and it is an aging station, that this was a pretty necessary improvement for New Zealand.